In today's class, let us study about how to write a chemical formula of compounds. So, before that we have to study what is a molecule, what are ions, what are atoms, and what are polyatomic ions, etc. These are few things that we have to learn before knowing this, how to write the chemical formula of the compounds. So first of all, let us see what is a molecule. Okay, so what is a molecule? Like we all know about atoms. Atoms, the simplest, smallest entity of anything. So but when two or more atoms combine together, so chemically they combine chemically together, so then molecules are formed and they're held tightly by strong attractive forces. Okay, and for this molecule, the law which is followed is law of constant proportion, and in this, whatever the elements are combined, the mass is fixed. Like in the formation of ammonia, so one atom of nitrogen is used and three atoms of hydrogen is used, and the ratio of the nitrogen and hydrogen in ammonia is always 14:3, because mass of the nitrogen is 14 and mass of one hydrogen atom is 1, so that will become 1 into 3, so it will become 14:3. So whatever the source of the ammonia, so it will be in the ratio of 14:3 by mass. Okay, so the molecules are of two types, and how they are formed, like molecules are two types: molecule of elements and second is molecule of compounds. So molecule of elements, like I told you, ammonia, in ammonia two elements are there, like nitrogen and hydrogen, so they are combined and the molecule of elements are formed. And one more example I can take: molecule of water, like H2O. In the H2O is also the example of molecule of elements in which two hydrogen atoms are there and one oxygen atom is there. Okay, so this is molecule of elements. And number of atoms present, one more thing here is that is atomicity. The number of atom present in the molecule represents its atomicity. Like hydrogen, it is H2. So we in hydrogen, this hydrogen is a molecule, right? So hydrogen is a molecule, then formula is this H2, because in hydrogen two atoms of hydrogen, they exist together, they come together and form bonds, and in this way they stabilize itself. And in hydrogen H2, so we say the atomicity of hydrogen is 2, because two hydrogen atoms are combined to form the molecule of hydrogen. Okay, similarly in oxygen atom, two atoms are there to form oxygen molecule. Okay, and in ozone, that is also a molecule of oxygen. So in ozone, the three oxygen atoms are bonded together, so their atomicity is 3. And in phosphorus, 4 phosphorus atoms are bonded together, so the atomicity is 4. In sulfur, it is polyatomic, but to be very precise, it is octatomic, or it is S8. So 8 sulfur atoms are bonded together to form one molecule of sulfur. And in chlorine is also diatomic, that is Cl2. Helium is monoatomic, like its atomicity is 1, because helium is an inert gas and it doesn't bond with anyone and it exists independently. So helium is He only, so atomicity is just 1. And same way argon is also inert gas, so it is also written as Ar, and its atomicity is again 1. So this, I think this is clear now, so that we can say what is atomicity. The number of atoms present in the molecule represent the atomicity. Okay, and these are the atomicity of the different molecules. You can learn from here and help you. Okay, next thing is my molecule of compounds. In the molecule of atoms, only 2 atoms are there, but in molecule of compounds we have the atoms of different elements are combined or bonded together by chemical bonds. These are present in definite proportion by mass according to the law of constant proportion. These molecules of compound can be diatomic, triatomic, tetraatomic and polyatomic, like hydrogen chloride, water, ammonia, carbon dioxide. Okay, so these are molecule of compounds. Like you had 2 different atoms are combined, like hydrogen and chlorine. In hydrogen chloride, the hydrogen and chlorine are combined together, and there are two atoms like hydrogen and chlorine, so two atoms, so it is diatomic. In water, water can be written as H2O, and there are two atoms of hydrogen are there and one atom of oxygen is there, so it is triatomic. In ammonia, one atom of nitrogen is there and three atoms of hydrogen is there, so it is tetraatomic. Total 4 atoms are there, so it is tetraatomic. In carbon dioxide is CO2, one carbon is there and 2 oxygen atoms are there, so it is triatomic. So this way we can write the molecule of compounds. We have many more molecules of compounds, and like H2SO4, we have H2SO4. What is H2SO4? This is sulfuric acid, okay? This is sulfuric acid. So how many atoms are there? How many atoms are there? 2 hydrogen atoms are there, 1 sulfur atom is there and 4 oxygen atom are there. So total atoms are 7. So 7 atoms are there in this sulfuric acid molecule. The compound of this. This is the molecule of compound. Okay. So we can find out how we can calculate the atomicity of this molecule of compound as well. Okay. So next my topic is what are ions. So what are ions actually? Like you see, in case of we see like in NaCl. What is NaCl? NaCl is sodium chloride. Okay. In sodium chloride, if we split it into two, so it is, when we put it in water, it breaks down and forms Na plus or Cl minus. So these are, and this is cation. Na plus is cation and Cl minus is anion. So what is cation and what is anion? So the ion which is positively charged is cation, and the ion which is negatively charged is anion. Mostly the metallic and this metallic Na sodium is metal, so they are positive, carrying positive charge, and the anions like non-metals, they are carrying negative charge. So NaCl, in NaCl the cation is Na plus and anion is Cl minus. Okay. So the compounds, so you see this in sodium chloride we have, this is a compounds composed of metals and non-metals, and they contain charged species. And actually these compounds are neutral in nature, because whatever is the positive charge, that is same is neutralized by the negative charge. So these charged species are known as ions, and these ions can be positively or negatively charged. A negatively charged ion is called anion, that can be Cl minus, S2 minus, and they're carrying the particular charge depending upon their atomic number, etc. So a positively charged ion is called cation, like Na plus, Ca2 plus and Al3 plus. How much charge they are carrying, that will depend upon their structure. What is their structure, what is their atomic number, so that will be depending upon their atomic number. So accordingly we can say what is their charge, that we can learn in the next class. So okay, these are ions, these can be positively and negatively charged, and the positive and negative when combined, they form a neutral molecule like NaCl. Okay, so in next is my topic is polyatomic ion. So if a group of atom is carrying a charge, then it is called polyatomic ion. You see in this NaCl single atoms are there, but if we see the example of calcium carbonate, or calcium carbonate or calcium hydroxide, let me take calcium hydroxide, CaOH whole twice. Okay, so in this case calcium is 2 plus and OH minus is carrying 1 charge, but the 2, so its charge is taken as 2. No, it is having 1 charge actually. So 1 here, calcium is 2. When we cross multiply it, we get the formula Ca1 and OH whole twice. So here you see the group of atom. OH is a group of atom. Okay, so group of atom, and it is carrying a charge, 1 minus charge. So it is a polyatomic ion. Okay. This is a polyatomic ion. Okay. Many more polyatomic ions are there. We'll discuss later on. So valency, next my topic is valency. So valency is the combining capacity of elements. Okay. So what is actually combining capacity? Let me tell you. So one thing is like valency of charged species. Like I told you, in case of OH minus. So the OH minus, the charge here, the charge on OH will give you the valency as 1. Okay. So and okay. So this charge will give you the valency as 1. The valency of charged species is the charge present on them. Correct? So we can take more, like I'll help you in making, like any I take any. So what is the valency? Let me help you in this. So Na, the atomic number of Na is 11. Okay, and its electronic distribution is 281. So in the inside it is nucleus having 11 proton and 12 neutrons, and there is in the first shell only 2 electrons can accommodate in the first shell. In the next shell 8 electrons can come. So this is 1, 2, 3, 4, 5, 6, 7 and 8, and so 2, 8 is done. Now only 1 electron is there. So 1 electron will come in the next shell. So you see here, there is in the outermost shell there is only 1 electron. Okay, so this 1 electron will give it a valency as 1, because valency as 1, because it want to remove its 1 electron as soon as possible, because after that it will attain the stability, and so it wants to remove that electron. So that's why the valency is 1. So we are saying it the combining capacity of the atom, that we call it as valency. So in case of like calcium, we can take calcium atomic number is 20. Okay, the configuration is 2, 8, 8 and 2 again. So in this again nucleus is in center, proton and neutrons are there, and the 2 electrons in the first shell and 8 electron in the next shell. 1, 2, 3, 4, 5, 6, 7 and 8, and in the next shell we have again 8 electrons. Okay, and 2 more electrons are there, so they will go in the next shell. So they will go in the next shell. 2 electrons are there. So the valency, there are 2 electrons that it wants to remove. So its valency is 2 only. Valency of calcium is 2 only. Correct? So this way we can calculate the valency of the elements. So these though we can have in the next class also, because this is a very important topic, and we have to, all the chemistry is based on this thing only, valency, how the elements combine, how they attain stability, etc. This we have to learn in detail. So I had drawn here some cations and anions. You see, like cations are there, hydrogen H plus, potassium K plus, sodium is Na plus, and barium is Ba2 plus, calcium is Ca2 plus, magnesium is Mg2 plus, zinc Zn2 plus, aluminium Al3 plus, and iron Fe3 plus, copper Cu2 plus, and ammonium NH4 plus. This is only cation which is polyatomic actually. Otherwise all these atoms are single atoms are there, they carrying charge, but here it is polyatomic ion ammonia and having plus charge. Okay, so few anions are also there, like chloride is Cl minus, bromide is Br minus, iodide is I minus, hydroxide is OH minus, nitrate is NO3 minus, nitrite NO2 minus, and nitrite N3 minus, bicarbonate HCO3 minus. Then these are charge actually. Cl 1 charge, bromine 1 charge, bromide is 1 charge, iodide is 1, OH minus again 1, nitrate is 1, nitrite is 1, and nitride is carrying -3 charge, and bicarbonate it is carrying -1 charge, and sulfite is carrying -2 charge. So the charge it is giving the valency. Okay, so in case of like formation of the compound, like in chemical formula, we use this charge only as the valency because it is polyatomic ion. So for the in case of ions, we have to use the charge as its valency. So for carbonate it is CO3 2 minus, sulfate is SO4 2 minus, sulfite SO3 2 minus, phosphate is PO4 3 minus, and permanganate it is MnO4 1 minus, and dichromate it is Cr2O7 whole 2 minus. So I think this is clear now. So this will give you the valency, the charge, the polyatomic ion carrying the charge will give you the valency. Okay. So now we have to now our topic is how to write the chemical formula of simple molecular compounds. So these are like carbon dioxide, zinc oxide, and aluminum oxide. Okay. So this, let me help you. Like carbon dioxide, or we can take zinc oxide. Let us say zinc oxide. Okay. So for zinc oxide, what we will do? For zinc oxide, we will write the symbol Zn and O. This is cation and this is anion. So I'll write the valency now. The valency of zinc is 2 and valency of oxygen is 2 again. So I'll then cross it. On crisscross I get Zn2O2. Okay. So then both of the atoms are having 2 atoms. So this will be they'll cancel each other and the formula will be ZnO. Okay. So the formula of zinc oxide is ZnO. Next is aluminum oxide. So let us write the symbols Al and O. So now valency of aluminum is 3 and valency of oxygen is 2. So on this crisscross we will get Al2, okay, Al2 here and O3 this way, Al2O3. So the formula will give you the aluminum oxide is Al2O3. Now my next thing is sodium phosphate. Na phosphate is PO4 and Na is carrying 1 charge and PO4 is carrying 3 charge. Okay, so it will give you what? Na3PO4. Okay, this is sodium phosphate. Ammonium carbonate will be, ammonium is NH4 and carbonate is CO3. So it is having 1 charge and it is having 2 charge. So the formula will become NH4 whole twice CO3. Okay. So this way you can try writing more. Like calcium hydroxide is Ca and this is OH. So that its valency is 2, calcium valency 2 and OH is having 1. So then I'll cross it. So I'll get CaOH whole twice. Okay, we don't need to write 1. So like Ca1, it will not, like, it doesn't matter. So we can write directly CaOH whole twice. Like aluminum hydroxide, so Al and OH, and I told you the valency of aluminum earlier. Can you guess? Yes, it is 3. Yeah, aluminum is 3 and OH is, yeah, this is 1. Okay, so I'll get AlOH whole 3. Okay, and now is sodium carbonate. Sodium is Na and carbonate is CO3. The valency of sodium I told you by drawing also. So tell me, yeah, this is 1 and CO3 is 2. On crossing I'll get Na2CO3. Okay, calcium phosphate, calcium is Ca2 valency and phosphate PO4, it is 3. So I'll get Ca3PO4 whole twice, because this polyatomic ion and there are two polyatomic ions are there. So we will have to put them in bracket and then I have to put 2 over there. Otherwise, if I just write Ca3PO4 2, so that means oxygen will be 8. So that we don't write that way. We have to write the polyatomic ion in brackets only. Then ammonium sulfate. Can you guess the valency of ammonia? Yeah, this is 1 and sulfate it is 2. On crisscross we will get NH4 whole twice SO4. Okay, so this way we can write the formula of the chemical formula of the molecular compounds. Okay, so I have written few more for your for your reference, and you can note it down, and you can draw write the formula, chemical formula of the compounds like ammonium sulfate, sodium hydrogen carbonate, calcium carbonate, ammonium chloride, sodium sulfate, magnesium hydrogen carbonate, magnesium nitride, and hydrogen sulfide, and carbon tetrachloride. If you have any doubt in this, you can ask me by writing in comment box Okay, here I have written the few rules for this, how to write the chemical formula, for steps for writing the chemical formula. So first we have to write the symbols as by side, then we write the valency at the bottom, and the crisscross method is then applied to arrive at the final formula. Like the final formula is H1Cl1, and we can write it as HCl because 1 we have to ignore. Okay, if the ionic compound contain compound ions like ammonium carbonate, so ammonium is NH4 and carbonate is CO3, we write here charge valency in place of like valency, we write charge. So this way it is, the formula of ammonium carbonate is NH4 whole twice CO3. Okay, so I think this is done now. So in the next class we can do few more